is one of the special form. This is not exact special form. I am going to discuss one of my favorite sum of integration, and throughout that sum I am going to discuss one special form. This is integration of root tan theta or root tan x dx. So first substitution what I will do, I will write tan x as z. Tan x as z means differentiating sec square x dx will be equals to dz. Right? So sec square x dx as dz. So sec square x can be write as 1 plus tan square x. So dx will be dz divided by 1 plus tan square x. Tan x is my z. Tan x is my z. Or rather, if tan x is under root, if I take tan x as z square, if I take tan x as z square, this will be easier for me. So it will be 2z dz, and tan x is z square, so the sum will be z to the power 4, right? So the sum is now going to transfer tan x as z square, that is integration of 2z dz divided by 1 plus z to the power 4. I think I missed out one thing. Tan x as z square, dx is 2z dz, so one more z will come for tan x, because tan x is root over of z square, right? So the sum is integration of 2z square dz divided by 1 plus z to the power 4. I have already warned you, this will be a huge sum. So next step what I am going to do, I am going to divide numerator and denominator by z square. If I am going to do that, it will be dz divided by z square plus 1 by z square. Is it fine? I am going to add and subtract one term, and this term is 1 plus 1 by z square, 1 minus 1 by z square. What's my motto? I am just going to discuss this thing. So if I add them, I will get 2, so nothing I have to divide or multiply, things remain. Now what my motto is? Just check 1 plus 1 by z square. What I will differentiate to get this? Like if I integrate this, what will I get? If I integrate this with respect to dz, this will be z minus 1 divided by z, right? And if this is coming minus, so this thing will be plus, right? Now can you see any link? Can you write this thing in this term? In class 9-10 you have done a square plus b square formula, which is equals to a plus b whole square minus 2ab, or a minus b whole square plus 2ab, right? You have recalled this? So I will write it as 1 divided by 1 plus z square dz divided by z square plus 1 divided by z square. This is one part. And my second part is 1 minus 1 divided by z square into dz divided by z square plus 1 by z square. Already I taught you. So for this, now a square plus b square, I can write a square plus b square as a plus b whole square minus 2ab, or a minus b whole square. Which one I will write? Just check. To get z 1 plus 1 by z square, I need to take z minus 1 by z something. Z minus 1 by z, if I take z minus 1 by z as something, then only I will differentiate and I will get 1 minus z square into dz as the differential, right? And what will happen for 1 minus z square? For this, if I will take this as plus, then only I will get this thing minus 1. Ready? So first one I will write it as z minus 1 by z whole square plus 2 and 1 plus 1 by z whole square dz, and second one I am going to write it as z plus 1 by z whole square minus 2, and numerator is 1 minus 1 by z square. This is not the substitution, this is I am showing why I had done this part. Now I am going to do the substitution. What substitution? First substitution will be, if I take z plus 1 by z as u, if I differentiate I will get 1 minus this into dz equals to du. And next one, z minus 1 by z equals to v. If I differentiate 1 plus 1 by z square into dz equals to dv, right? So the first one will be, just check, first one will be integration of v square plus 2, and this will be dv, right? And second one is u divided by u square minus 2. Is it fine, all of you? I just forgot to write it in the color of red. So the thing is, what is the formula? What is the formula of integration of? It's a huge sum. So v square plus root 2 whole square plus this I am writing as u square minus root 2 whole square. So formula for this will be 1 divided by a tan inverse root over of x by a, right? And formula for this will be 1 divided by 2a log of mod x minus a divided by x plus c. This is your rough calculation. Is it fine? So the sum will be 1 divided by root 2 tan inverse. What was your v? Z minus 1 divided by z by root 2 plus 1 divided by 2 root 2 log of, what was your u? Z plus 1 by z minus root 2 divided by z plus 1 by z plus root 2 plus c. For both the sum, inside this bracket, I am going to multiply numerator and denominator by z. What is going to happen? Just check. 1 divided by root 2 tan inverse. This will become z square minus 1 divided by z root 2 plus 1 divided by 2 root 2 log. This will be z square plus 1 minus root 2 into z divided by z square, this will be plus 1 plus root 2 into z. Is it fine? Just go back to earlier days. What was z? Z was equals to root over of tan x, right? If I'll put that value over here, z is equals to root over of tan x, it will be z square is tan x minus 1, z is root over of tan x. So can I write this as root tan x? Root over of 2 tan x, it will be root tan x into root 2 equals to root over of 2 tan x. So next one, plus 1 by 2 root 2, z square is tan x plus 1, again same thing I can do it for here. So root over of 2 tan x, I just forgot to write this in the previous line. So divide by tan x plus 1 plus root over of 2 tan x. This is not the one integration sum which is difficult and which is taking longer time. There are many more integration sum which will take longer time. You will face it difficult to solve it. So please write me in the comment box so that I can solve it for you. Thank you.